الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
السلام عليكم ورحمة الله تعالى وبركاته. أعتقد أن الصوت واضح ويمكننا البداية بإذن الله. معكم عليان عبد النور، جي زوزو، ومعا بإذن الله سنتعلم مبادئ في الكمبيوتر نتوركس، يعني في السحابيات مبنية على الكمبيوتر نتوركس. لهذا أردت أن أعمل هذه السيشن حيث ستكون مبادئ فقط، يعني سأعطيكم الكثير من المبادئ. السلايد سيكون متوفر طبعا في الأخير ويمكنكم طرح الأسئلة. السيشن ستكون بالإنجليزي، ستكون هناك بإذن الله سيشنز بالعربي، وإذا كانت لديكم أي أسئلة يمكنكم طرحها. Hello everyone and welcome to this session. I'm Aliane Abdenour, GT Zuzu, Azul Fallouni. I'm from Algeria, and here we will today try to understand a lot of concepts about computer networks. So I will give you the basics and then we will see what's going on the cloud. So let's start. And of course, if you have any questions, you can ask them, and the slides will be available at the end of the session. So let's begin. Before we will start, I wanted to show you just a basic architecture that we use every day. We have a modem. Of course, don't worry. This is the big picture, and then I will detail them one by one. We have 1 hour together. Don't worry. So this is internet. This small cloud is internet, and then we have this. So everyone at home, it has his own installation, but we have always a modem, and then we have a firewall, and then we have a router, a switch. We give you the differences, and then we will connect using a laptop or a phone or a tablet, and then we have a professional switch and so on, printers, everything. So this is just a big image. What we do in networks, what I am doing right now, what you are seeing right now, it's just a letter. I'm talking on a microphone, I'm recording a voice on streaming, but what happens, I'm just sending you letters, and this letter is sent on a network. It has its basics and it has its protocols. So a letter, what we need the letter itself, and then we need the envelope. So when we send a letter, we can't send just a letter. We need to envelope it and then put the address and respect how we are going to write this address. Generally in the back, we put the destination, and in the front, we put the source. So let's now dive step by step in the concepts. So when we are connecting, we need two things. We need a MAC address, which is unique, which means that on the phone we have our own MAC address, on the laptop we have our own MAC address, and so on. And then we have what we call a network interface controller. So a network interface controller, this is it. So for example, in my laptop, I have a network interface controller, which has this place where I put the cable that I will tell you in a few seconds what is it. And then I have a Wi-Fi connection. In the recent laptops, sadly, this is being dropped. so you need a converter. Anyway, and because we are using virtualization, we will use what we call the virtual network interface controller, which can have 1 or 2 or 3 or 4 or whatever. And then we need to understand what is a protocol. A protocol is just a kind of behavior. We have two persons, for example, before I talk, I tell you Assalamu alaikum, and you reply by Alaikum salam wa rahmatullahi ta'ala wa barakatuh, and so on. This is just a protocol. So we put some rules between humans, and because we need to understand our behavior. For example, if I want to shake your hand, I will not use my left hand. I will use my right hand, because this is the protocol that we use. And the computer do the same, because we have two computers talking to each other, or two phones talking to each other, or a phone with a computer. They need to talk in the same protocol to understand each other. And then we need to understand what is I3E. This is just engineers that try to evolve stuff. And then, because we always find this word, and then we find the RFC. RFC is a request for comment. So engineers or developers put something on internet, and people, developers and professionals, come there and tell what they think, and then they validate it, and then they make it a standard. So they are just standards, in case we will see them later. So when we connect, in the past we use cables. Right now I'm using Wi-Fi, that's fine, because this is future, but in a professional domain or in a more secure domain, we need cables. In the cables, we have two words. I need you to make the difference. So let me enable this tool between this and, so sorry, is my sound, it seems that my sound, it's not that clear. Let me check. Let me check. Sorry, because I'm using Ubuntu, and in Ubuntu it seems that there is a bug. So let me fix that. Okay. So this is, sorry. This is the sound. So maybe if I put it to the max, something like this. How about now? I think now the sound is better. Okay, I hope it doesn't drop, because the Chromium browsers, they use WebRTC, which has this option to drop the sound. So I will do my best. I hope it will. Oh. Is it clear now? Okay, perfect. Thank you. So just an information, Pulse Audio has a bug. I don't know why, because I was using Windows, and then now I'm using. Okay, we'll continue. Sorry for that, because I just installed Ubuntu for this purpose, because I have a lot of stuff to show you that I can't do on a virtual machine. That's why I installed it in physical. So I'm sorry about this. We will do the max. Okay. So let's go back here. So we need to understand that there are two main differences between some cables. We have the RG and we have this RG. So this RG is the coaxial. We use it on, for example, on television or for example, to the receiver. And there are old installations that still use the coaxial. But now we use a lot the RG11 and the RG45. The difference is that the RG11, this is it. And this is the coaxial. The RG11, we use it in the phone to connect our landline phone. And the RG45, we use it in internet. This is what we use here, the RG45. So remember, every time you hear about the Ethernet cable, we are talking about RG45. So let me clear this screen and continue. So when you go and buy the RG45, you need to understand that there are many types. We have the category 5, category 6, 6A, 7, and 7A. When you go and buy your cable, please don't buy a category 5. They are deprecated because the maximum that can transport is 100 megabit per second. And you have the maximum, which is 100 meters. But the category 6, what they did, they added more bandwidth, but they sacrificed the distance. And then we have the category 6A, which is the update to the 6 to have longer distance with better connection. So if you want to buy cables, please buy those cables, 6A or 7. Don't buy 5. This one, just forget it. Forget about category 5. They are useless. They are obsolete. So if you want to buy a cable, use 6A or 7, or even better, 7A. But the future will not use anymore the copper and nuhas. They will use the fiber era. We are in the fiber era, and the fiber, what we call the fiber optics, we use two kinds of technologies, the laser and the LED. So the single mode uses the laser, which is really expensive, and then with multi-mode, we send a lot of lights, we use the LED technology. So you need to understand those two kinds of technologies. This one is expensive, this one is cheap. Okay, we continue. And this is just a small difference between the copper and fiber optics. Notice that the fiber optics can even live longer, and they don't consume a lot of energy. This is why it's the future. And the most important thing is that we can go further, and then we can send a lot of data on fiber optics. And we have the air. We connect using the Wi-Fi and so on. So we are not going to talk about 2G, 3G, 4G, and 5G and WiMAX. By the way, the WiMAX, it was a fail. I don't know why, but it failed. So we are just saying what is WLAN. You need to understand one thing, that there is a difference between WLAN and the Wi-Fi. The WLAN, this is for wireless local area network, but the Wi-Fi, this is the commercial version. This is like wireless fidelity. So to put this logo on a machine, they need to pay. So Wi-Fi doesn't mean WLAN, but WLAN doesn't mean Wi-Fi. So this one is a commercial. So the general term we use is WLAN. And the Wi-Fi itself, you will find this number, 802.11. Notice that we always find 800 because this is just a protocol. The engineers put a special protocol, and you will always find 800, 800, and the 800 itself, we have 802.11, and we have the A, B, G, N. A lot of houses use the N. This is the best, but right now we are here. We are in the Wi-Fi 6. Why we use the Wi-Fi 6? Because we need the IoT, because they get better, larger bandwidth, and better connection. So if you want to invest on a router, on a Wi-Fi router, you need Wi-Fi 6. Don't buy Wi-Fi 4. Just buy Wi-Fi 6. It's true they are expensive, but you can find good deals. Okay, now let's define what's a router, what's a modem, and so on. This one, it's a modem. So let me clear this. A modem is, we have a signal like this, analogic, and then what we try to do with a modem, we try to make it digital, 1 and 0. Because when we have here, we have a 1. When we are here, we are 0. But the signal from the ESP, they send it as analog like this. But this one is digital. So the role of the modem is modulation, demodulation. Modulation and demodulation, this is the process of converting the analog signal to a digital signal. And then we have the router. This is what we use to connect. This one is called the hub. And then the hub, sorry, it seems that yeah. The problem is, it seems that the sound is so bad. I'm really sorry about this. So if I do this, and how about now? Is it better? Yeah, I changed the device. Yeah, now it's better. Ah, thank you. Yeah, because maybe it's the algorithm that tries to reduce the noise. At the same time, it kills it. Anyway, today we know something. Don't try to use a recording with Ubuntu. Just a mess. Okay. Sorry for that. Let's continue. Okay, we have our technologies. So we have the modem. So let me bring back this. Let me clear the screen. So we said the modem is modulation, demodulation. We have the router, we have the hub, we have the bridge, and we have the switch. All of this in 2021 right now, we can find them in one single device, but it's better to have them separated. So the ESP who gave us the internet, generally, they give us those three: the modem, the router, and the switch in the same device. So if you turn back the router, you will find 4 hubs, 4 entries, 4 ports, and then you will find something that we can see. This is the modem, and then we have the form that we all know, which is the router. So the modem, it's used to modulate, demodulate, modulation, demodulation, converting signal. The router is to show in the routes where our data is going, and the switch is to split the connection. And we will see what does it mean, split connection. So the problem is that in the past we used this, which is the hub. The hub is deprecated. Why is it deprecated? Because it uses what we call the half duplex. Here is what does it mean, the half duplex. So let me switch back and let me draw you something. Okay, we have machine 1, we have machine 2, and we have machine 3. And we have in the past what we call the hub. So the hub is just a splitter. So if we send the data here, and then this one is connected here, and this one is connected here. The problem with the hub is that it just split the data, which means that if this one writes to this one, he wants to contact him, what happens is that even this one will receive the data, which is bad in security. And there is even worse, is that it gets congested. So what we mean by half duplex, that means that if I talk, I cannot listen at the same time. So half duplex is that if I talk, I only talk, I cannot listen. But if I listen, I cannot talk. This is, for example, like the walkie-talkie, the talkie-walkie. So to talk, you need to hold the button, and then to listen, you need to release it. This is what we call half duplex. And just forget about the hub, we don't use it anymore. Let's see what is the next technology. Then we invited what we call the bridge. The good thing with the bridge is that it brings what we call not really splitting the data, but I want you to understand the switch and not the bridge, because the bridge, it contains the maximum 4 ports, and they don't use a special technology that we will see later. So I will better explain using the switch. So the switch, before I go there, please don't buy a cheap switch. Just buy what we call a fully configured switch. For example, Cisco or Juniper. Don't buy a switch just because it's cheap, because you cannot configure it. And what we say fully configured, this is not because you can change the password or change add the Wi-Fi network. That means it's configured. No, that means that you just do it for a home utilization. But if you want a professional that we'll see in few seconds, you need to buy a fully managed switch. Don't buy a switch that they say this is just a switch. No, search on it on internet, you must find it fully managed. And before we understand how switches work, we need to understand what is the Aussie model and what is the TCP/IP model. So internet is using the TCP/IP protocol. So let me explain you one thing. So if I want to contact, right now we are seeing this presentation on internet. So what's going on is that the data, we are here. We are in this layer. So this layer, this is for people. This layer, this is for electricity. We send binary signals here, but we use, as user, we must see things here. So in the application layer, we have the presentation, we are seeing what's going on, but we are sending the data like this. And then when you receive the data, you will receive it like that. But this is for internet. So people in internet, they talk TCP/IP. But when you go to the hardware, people talk Aussie. Aussie, simply, why we use Aussie? Because the 7 layers, they are explicitly separated. But the TCP/IP model, we have here 4 layers grouped, and here 2 layers are grouped, because we are using software. But in hardware, we need this. Now, why we need this? Because we need that. So let me delete this stuff. We are doing what we call encapsulation and decapsulation. When we send something to the space, in reality, we don't need the whole thing, but we need the whole thing to help it fly. But once we are in the space, we throw everything and we only keep what is the most important, like this presentation. So if we have data and then I want to send the data, what I do, I will encapsulate it. So let me delete this. So the more I go to the bottom, the more I add data. So every layer is specialized in a kind of data. So every layer, it will add something. And this is exactly what I explained to you with this. So a letter, this is just, we need the data. This is the data. But every time we try to send it, we encapsulate it in something. We add the letter, we add the envelope, and then we add, for example, the stamp, and then we write the address. And this is how it works. So if we come back to the layers, the network people, they will talk about which layer they are. So they will say, we are in second layer, we are in third layer, we are in fourth layer, and so on. So every time you hear someone from networking, when he says it's in third layer, they mean the third layer in the Aussie model, which is, for example, the Aussie, which is the network layer. First layer, second layer, and so on until the seventh layer. So we will try to talk like network people now. So we encapsulate and decapsulate. And this is the switch. So to explain you the switch, let me draw something weird and then explain you in detail. So let me go back here. So I don't need this anymore. So we have the three machines, and then we need to send them. So I have this one, I have this one, and I have this one. We said that in the hub, that if I send something here, those two people, they will hear it. And then if I want to send it just directly here, the problem that even this one, it will get the data. The switch, it is the same thing in the beginning. Even this one will hear it. But the difference is that he will control that the message is not from him. So the second message, he will just ignore it. Only this one will get the message. This one, it will keep dropping it. How this is working, how this works, just by learning, because the first phase, it's called, let me write something here in black. This is called the broadcast. So broadcast, it's a broadcast domain. So what I do, I send a message and then all of them will hear about it, but only the one that has a MAC address, because here we don't know what is the IP address. In switches, we only work with MAC address, which means that we are in layer 2. So when we are in this layer, we are only using MAC address, and once this one, for example, it has a MAC address AA, this one is BB, and this one is CC. So the CC, if it wants to send to the AA, the first time it will broadcast the message for all of them. And this one, he says, hey, this is not for me. So next time I will just drop it. Only this one will receive it. And the good thing with the switch, it's a full duplex, which means that I can write and I can read at the same time. But people don't use the switch only for this. They use the switch to configure what we call a VLAN. So let's say that, let me go back, okay, or let me just delete everything. Okay, I have first machine, second machine, third machine, and fourth machine. And then we have a switch with, for example, 24 ports or whatever. The problem is that since the broadcast at the first time, it can see everyone, we have a security concern. For example, here, these people use money. These people use the people information. And this is, for example, the director. And for example, this, I don't know, maybe it will expose it for people in, for example, who come there as a guest. The problem is that those people can see what this and this and this are sending as data. So what we do, we have two solutions. We buy, everyone we buy for him a switch, and this is expensive. Or we just split them in a logical manner. How we are going to do this, we just bring this machine, let me make it, and we say, hey, this port is only reserved for those people. This port is only for these people, and this port for those people, and so on. So we are separating them in a virtual way. And this is why we call it VLAN. VLAN is a way to use one switch, but separate the department, for example, to have this one. Let me write in black. It will have its own broadcast domain. And this one, it will have its own broadcast domain and so on. But we'll back later when we will talk about IP address. So since everyone is using its own broadcast domain, no one can hear the other one. And this is like you bought 4 independent switches. So the VLAN, it uses the MAC address. It doesn't use the IP. Okay. And generally, the capacity of switch, we can find 10 gigabyte, 1 gigabytes, 100 megabytes, 10 megabytes. This one is deprecated. Just don't buy it. This one and this one. Now we are in gigabyte Ethernet, and you can even have 40 gigabyte and 100 gigabyte. But when you find it's written like this, that means that it's retro compatible. It can work with this, it can work with this, and it can work with this. And the full capacity, well, you need to understand that this value is just for one port. So generally, you will search about the backplan. The backplan is how much capacity it can handle, which equals to the capacity by port multiplied by all of them multiplied by 2. The 2 because you are in full duplex. So if we have 1 gigabit per second, we will have 48 multiplied by 2, which is 96 megabit per second. And generally, you will find the best one that are used in the market. They are Cisco and Juniper. The Cisco, it uses an operating system based on Linux, which is called iOS, which is not for iPhone. And Juniper, it uses the Junos OS. And the VLAN, we explained them. So let me delete this and continue. This is the VLAN, and then in the VLAN, we need what we call the trunking. The trunking, let me go back to our board. So let me go back here. Let me select everything and delete it. So the problem, we always think how we are going to use less hardware and virtualize everything else. So here is a problem. Let's say that we have a machine here, a machine here, a machine here, a machine here. We have a lot of machines. And then we have 2 switches. Okay, this drawing is bad. We have 2 switches, something like that. And then we connect this here. They have their own VLAN. And then we connect this here, they have their own VLAN, and then we connect those ones here. So at the end, we will find 3 VLANs. So 3 VLANs, they need 3 cables to connect the switch 1 with the switch 2. The problem is that what if we only use 1 cable? And this, we use what we call the trunking. The trunking, what happens is that once it gets the data here, it adds an ID to tell him this is the VLAN coming from ID 10. This one comes from ID 20, and this one, it comes from ID 13. Now, you say, why you don't use ID 1? ID 1, don't use it. This is a reserved ID, and by security, this is bad. So never ever use this. Try always to change it. So the ID 20, ID 30, ID 10, and once it gets here, it will send it with the ID, and then the machine will know it. But we need to install this protocol here. And this protocol, we call it the 802.1q. And this is the protocol we use in trunking. But we always avoid loops. What is a loop? I explain you again with something. So let's delete this. Let's suppose that we are using a bridge, because it happens when they invented the bridge. So we have 3 machines, and then we have a bridge. So what happens? This is a bridge, but in reality, here is how we are connecting. So if I bring here and bring the color here, okay. So let's say this is, we go here, we go here, we go here. This is a problem in computer networking, because what we are doing, we are using a loop, and we are stuck in the loop. What happens when this is, we call it a storm. We are storming the table about the MAC address. So what happens? Our network shuts down, and this is why we need a protocol that will avoid this. So what happens? We decide which will be the master, and then we tell him, okay, maybe we should never take this route. Never. So what happens if I want to contact this? I go there. But if I want to contact here, I do something like that. But I never go there. Why? So I don't allow this one to go here. So this protocol is called STP, for Spanning Tree Protocol. This Spanning Tree Protocol is to avoid a network loop. And when you are stuck in a network loop, your network goes down. So you need to understand this. And because it was invented for bridges, now it's used in switch. So if you have already heard about it in switch, you need to understand that it was invented for bridge. And there is something else I need you to understand. You need to understand one thing. When we configure switch for a big enterprise, the big enterprise, they have different needs. So here, different needs. We have a VoIP phone, we have computers, and we have camera. The camera and the computer and the phone, they don't use the same data. So we need to separate them in a way to make the switch understand which kind of connection. And this is what we call quality of service. So the quality of service, we are reserving, for example, this port for phone, this port for computer normal, for data, for internet, for example, and this port for camera. And we configure this port to be special for video data, this one special for sound data, and this one for normal usage data. This is what we call quality of service. And this is why we buy a special configured device. And here we are in IP. You see, the IP, it's in, here we said physical layer, data layer, network layer. So as you can see, we call it internet layer, but in Aussie, we call it network layer. So here we have the MAC for the switch, and now we talk about routers. The routers are here, are in network layer. So we are in layer 3. And we all know what is an IP address, and it's in reality, it's written in binary. As humans, we use digital numbers, but in computer, it uses binary, and it's configured on 4 bytes. So the probability of having all of addresses is 4 billion. And 4 billion, in the past, it was a lot, but now it is not a lot. That's why we need the NAT. The NAT for network address translation, this is just, for example, I'm at home. Let me explain you what is NAT. NAT is this. We have a router, we have internet, and we have my phone and my laptop. So what happens? The ESP gives me the IP for my router. And once I get here, the router then, it will use the network address translation to know where it goes, where it will ship the data. Because if I can't use the NAT, I need to identify this and I need to identify this. So I will, instead of using 3 IPs with NAT, I will only use 1 IP. So think about this at larger scale. So if I put another NAT here, so imagine how we can save. And this is what saved us from IP exhaustion. IP version 6, I will not talk about this because this card is from yesterday. And as you can see in Africa, it's not even starting. So let's just forget IP version 6. And we have the private address. So the private address, they are kind of addresses that they are not allowed to go internet. But before we talk about private address, we need to understand what is classful and classless. Classful, just forget about it, because when they invented the IP addresses, they put it in classes. But when you put something in class, you lose a lot. That's why now no one talks about classful. Everyone just forget the classful. What we use at home, this is something like this, and we call it class C. But in reality, there is no more class C or class B or class A. So just forget about this. And what we use now is classless. So classless, the good idea is that instead of using classful, in classful, we only have 3 kind of masks, 8, 16, and 24. Now you can put whatever you want. So if you want, for example, 2 hosts, you use /30. Because in the past, if you wanted 2, you need to go and have 254 addresses, and you will only use 2 addresses, which is a waste. So you just configure it using a classless address. And then you need to understand that when you create what we call a subnet, so a subnet, this is just, we have a network, and then we create small networks. You need to understand that a VLAN doesn't mean a subnet, because in one VLAN, you can create a lot of subnets. So this is how it works. So if we have a network, we can create smaller networks at home, for example, and those are called subnets. And the subnet, even in one VLAN, we can create a lot of subnets. And then we create what we call a DMZ. A DMZ is where we put a server that we don't want it to go to internet, because in internet, we don't trust it. So we keep it secured. So we use a DMZ. This is language used in networking. And this is the router. So the router, this is what makes us go to internet, and the router uses the IP address, but the switch uses MAC address. So when you go and buy, for example, a professional router from Cisco, they will give you both the router and the switch bundled. And then we have the BGP, because in routing, we are writing how the packet is going. The packet is the element that we use in networking. So to tell him where to go, we need to configure it in a static way. You tell him, go here, go here, go here. Let me explain this better in schema. Okay, this is network. Let's go. Okay. This is a network. This is network 1, network 2, network 3. This is internet. So what a route, we tell him go here, then go here, then go here, and then go here. We try generally to choose the shortest path. So this is static, because we told him how to do. The problem is that if we add another network, we need to reconfigure all of this. So that's why we need the dynamic way to detect if we have a new network, and this is what we call a BGP. So BGP is a protocol that allows you to add nodes or networks without the need of configuring it. So now we are in layer 4, and in layer 4, we use the TCP or UDP. Right now, we are using HTTP. HTTP is based on TCP, And in TCP and UDP, we have the concept of ports. So for example, internet, we will see that in a few minutes. And you need to understand that the difference between TCP and UDP, this is like, let me go back here. So if I send my letter directly, I'm using the UDP. Why? Because I don't expect a response. I don't know if it's there. I don't know if it's been stolen. I don't know if it's lost. So I will tell the postman I want to have an acknowledgement, an ACK. The ACK, this is like, for example, in Messenger or in WhatsApp, when you send something, you get the famous scene or something like this. So this is the ACK. We send the letter and then we get back something to tell us, okay, your letter has been sent. But we have a problem is that we lose a lot of time. That's why TCP, this is a good protocol when we need something that acknowledges. But UDP, for example, in gaming, we use UDP because we send a lot of data. We don't care if 10 or 20 packets got dropped from 1000. This is the difference. So in UDP and TCP, we have the concept of ports, and the IANA, let me show you, they split them on lists. So for example, from 0 to 1023, they are reserved. To reserve this on Linux, you need to be super user. And then they are a user that you can allow. And then they put a list. For example, HTTP, they use 18. NTP for network, for the time, because when you have a lot of servers, you need to synchronize them. We use 1, 2, 3. FTP for file transfer protocol, we use two ports, one for data and one for establishing the connection. And SSH, secure shell 22. And for telnet, the old one, we use the 23, which is not encrypted. This one is encrypted. And you need to understand that SFTP and FTPS are not the same. FTPS is the FTP secure. This is like HTTP and HTTPS. But SFTP, this is FTP over SSH. So if you already installed SSH, you will directly have SFTP. And when we are in Windows, we use RDP. We don't use SSH. So if you install something on the cloud and you need Windows, you need RDP for remote desktop protocol, where you use the mouse in distance. SMB to share files, and in Windows we call it CFS, and in Linux we call it Samba. But the protocol itself, it's called SMB. NFS to share files, to create the NAS and SANs, like we saw in previous session. And SMTP, when we use, for example, Gmail, you need to understand that Gmail, when we go gmail.com, it shows us something in HTTPS, but when we send the email, we are not using it on HTTPS, we are using it on SMTP. Okay, and then we have the firewalls. So the firewalls, we have two types of firewalls. We have software and hardware care. We have what we care about is stateful and stateless. So Google uses the stateful because the difference between stateful and stateless, the stateless, we use what we call the ACL. The ACL is we tell him, okay, drop the packet that comes from this IP that comes from a port number something. So what we do, we give him explicit numbers. We tell him, if someone tries to contact you from here, just drop it. Or if we need to close the port 22. So here we use ACL, but stateful, we keep everything enter, and then we analyze it to understand if it's a good or a bad packet. So in industry, we use them both. Here we can use, for example, machine learning to detect that. I hope we are going better. So I wanted to say something about ECMP. ECMP, this is not something we use with port. Not like port 18, port 22. ECMP uses a special packet organization where they use two numbers. So don't ever try to block ECMP, because if you block ECMP, you can block your VPN, because VPN, sometimes it uses ECMP to make the first connection. So it sends a packet and then it tell him, okay, I need to split the packet. So if it doesn't get back something, it will stuck forever. That's why when you block ECMP, don't block it all, just block some codes. And we have the DNS. So when I type google.com, Internet don't know what is google.com. It knows what is the IP of the server of Google. So because we are humans, we need to use normal names. And this is what we call domain name server. But personally, when I'm inside the network, I like to call it device name server, but don't worry about my weird names, just call it domain name server. And then we have the fully qualified name where we use www.google.com. So this is the fully. So when you say www.google.com, it has three. It has the host, and it has the host name, it has the server name, and it has the root. So this is FQDN. And we have two types of DNS. We have encrypted DNS, and this is a new technology which is called DNS over HTTPS, and it will revolution how people will connect, because no one can know where you are connecting, because you need to understand that HTTPS, so if I type google.com/ABCD, Internet will always send this in clear, but ABCD, no one will know what is this, because this, it will be encrypted by the server where you are going. But this one, this is always DNS, and you can always read what people are using in Internet, for example, using Wireshark. That's why people like to use a VPN. What is a VPN? A VPN, just before we go, VPN, I bring you some lists of ports depending on which layer we are. And this is a VPN. So we try to create a tunnel. We call it a tunnel like this. So let's suppose that we are here. The server we want to connect is here, and we have a lot of networks. So what we do, we create a tunnel to protect you. So not only we create a tunnel, but we encrypt the data. And in case someone tries to hack this tunnel, the system will automatically break this tunnel and make you another tunnel, which makes it really secure. And we have two types of architecture of VPN. We have the remote access. For example, I want to watch something on Netflix that is only allowed for US people, so I will use a VPN from US to make Netflix think that I'm from USA. And I have the seat-to-seat, and the seat-to-seat, this is the enterprise-grade VPN. That, for example, I want to connect to a server on USA and make it think like I'm here in Algeria, so I use the seat-to-seat, and this is what we call the hybrid cloud. So the hybrid cloud, this is to connect to something on the cloud, making it think that we are on-premise. So that's why we never use this on-premise, because we can have two IPs that have the same address. So just use 10.0.0.0, and you can have, for example, /24. You are allowed to do that. Why not? Okay. And because we are in future, we are using now NFV, which is for network function virtualization. We are virtualizing our network, but we need, so if you want to use this technology in fully way, you need to buy a machine that has this technology, the VTD. The VTD, it uses a special way to virtualize your machine, but keeping your network, for example, network device, because you have a higher I/O input output. So you need to let it physical. So this is called VTD, and you have the Virtue. If you go to VirtueNet, you will have more definition about the VTD, and that's what you call. You hear a lot about the pass-through. For example, on Linux, if I want to virtualize something that I use an NVIDIA, I need to go by pass-through. Okay. And here we are in Google Cloud. Google Cloud, this is it. So please, can you add me, for example, 10 minutes? Yeah, that's perfect. Thank you. We can go and finish this. So in Google Cloud, what is the most important here is that you will see that it's global. Oops, sorry. So let me delete this. You need to understand that it's global. It's not by region. But if you go to Amazon, you will find it's in region. Why? What makes it global? We will see that. So before we go deeper, you need to understand that it's split in regions, and every region has a zone. So this is a zone, this is a zone, this is a zone, and every region. So if you host something here, in reality, you can have it here, but it depends. We will see that in few moments. So we have what we call global resources, we have regional resources and zonal resources. So the network is global, which means that if you have a network here, and subnet here, and the subnet here, in reality, you can consider them as one single network. How we are doing this? Don't worry, we'll see that in few seconds. And internal DNS, they use this kind of notation, the hostname.c.project_id.internal. And there is something I need you to understand is that the firewall is stateless, and you have the cloud NAT. This is the way to use, for example, to create a DMZ. For example, we have a server here, and we remove the public IP, and we only leave the local IP, because every machine has its own local IP, and we can still get there. So we can download or whatever, and then we can configure this using the cloud NAT. We will use that in future labs. So what makes Google use a network that is at global scale? This is called Andromeda, and Andromeda, this is the future that we call the SDN, the software defined network. This is not the NFV. There is a difference. The NFV, we virtualize everything, but the SDN, what we try to do, if we take a switch and a router, you need to understand that it's split on two things. We have the data plan, which is the hardware, and then we have the controlling plan. This is the management. So when we buy a Cisco, we have the router, which is the hardware, and then we get there to configure the VLAN and so on. So the fact that it's manageable, that's because it has the brain. So we have the hardware and the software. And then we have the management plan, which are the commands that we type. So this is the traditional way. But there is a problem, is that if we have a network, we need to configure them one by one. So if we have 10 switches, we need to get there and configure everyone alone. And then there is another problem, is that we are growing, and there is the Moore law. The Moore law says that every 2 years, you need to double the transistor, which means that the technology grows every 2 years. But reality proved that in 5 recent years, this is not the same thing. We see something change in 6 months, and this is what pushes Google to invent its own solution, because they will not depend on Cisco anymore. They will invent their own solution, because when you buy Cisco, you are locked on Cisco. I give you an example. If you use packet tracer, often, not packet tracer, if you use GNS3, and then you download the iOS virtual machine, let's call it virtual router, you need to understand that it's you will not get the full speed. You will not get, for example, the 10 gigabit per second. So for this, you need to download what we call the Open vSwitch, because Cisco it will lock it, and then it will say, okay, just buy the hardware. I will not give you the version in NFV. So just an information that you must know. Using GNS3 and packet tracer doesn't mean you are simulating the reality. You are near the reality, but not the fully reality. So what we do with the SDN, we try to centralize everything. So as I said earlier, if we have 10 switches and I want to configure them, I will make a server to make them all configurable in a central way. And in a central way, I will use the cloud power. And the cloud power, it has the AI and it has several things. So Google, they use an SDN for their networks, because this is the future. That's what makes it global. And let me delete this. If you want to see more about SDN, you just document about OpenFlow. This is the protocol it's used, and this is future. And this is the infrastructure of Google. These are fiber optics. So you can imagine how fast it goes. And those are caching areas. So I'm in Algeria. I go to, for example, Google Play. It will give me something from near to me because it cached here. And we need to understand what's the difference between premium tier and normal tier. So if we have a normal tier, I'm here and the ESP is here. So there is a lot of networks over here, and I have a server on Google here, for example, google.com. So what happens in normal tier is that I don't know my packet where it goes. It uses what we saw earlier about the BGP. So the problem is that it's not a static route, it's a dynamic route, because if someone makes a new connection, okay, I will add it. The problem is that I should never trust it. It's too trustful. That's why I need to go on a special server that Google gives us, and this is the premium tier. The premium tier, this is how it works. As soon as I get here, there is what we call POP. For example, here, it will make me enter here, and then it creates like a tunnel. And I will only use Google specialized connection. I will not go on public ESP and trusted ISP. I will only use Google proprietary network. And this is a simple schema. I have a normal tier. I need to do a lot of hops to get to my destination, but on Google, on premium tier, I will just go to my destination. I'm sorry I made it too long. Those are too many concepts. I see if there is, those are the slides. If you want them, you just go and download it. I see if there are any questions, and then I will do a small demo. So any question? No. And I'm sorry about earlier about the sound. Yeah, I know. So any question? The slides are here. So I will do a last demo before I end this. So let me escape this. And by the way, I was going to use this tool, but it needs internet. So this is, for example, you can go to auto draw. For example, I need to draw a laptop, a machine, and I have this, or I have this. You just need to be a good drawer. So it's free, it uses the AI, you can use it. Okay, this is my machine. I created two machines, Australia. I have a public address and I have a local address. If you notice, that's what we said earlier. When it begins with 10, this is internal IP. This is not exposed for public. And when it uses something like this, this is for public. So if I bring my console here and I do ping, sorry, if I ping to this machine, so 35, 189, 39, and 94. So I get a response. That's okay. Everything works. Control C. Now, if I ping to this local machine, so let me make it smaller. Sorry. Okay, let me just. If I'm 10.152.0.5 and I try to ping, see, nothing works. So you can create a DMZ using the cloud NAT in a way that you only get this and not this. And now if I want to get access to my machine, I use SSH. So if I go here and I just wait just for 5 minutes and we will finish. And just hurry. I just wanted to show you something important about SSH. Yeah, because I'm using 4G, so I can have a good upload, not a good download. So if I do ping, and I try to ping to the other machine, if you check here, what I have a machine in Australia and I have a machine in USA. So, of course, if I try to ping the IP address, the public address, it will work. But what I will do, since I'm in, oops, not this. What is this? Oh, not that. Oh, sorry. Too many. I'm in Australia, so I will try to ping the US one. So 10.128. And then if you see, I'm getting the response. This is like I'm in a small network, even if I'm in word scale. So my first machine is here. So my first machine is here, and my second machine is here. And I'm pinging like it was in 10.something.something, which means I'm in a private network. So last thing before we will end it, let me run something to show you. Here I'm in my machine. So if I do MTR, this is a trace route plus a ping. This shows you, or let me use another one. Okay, let me go to Australia. What I am using right now, I'm using Australia, so I will use the USA. So let me copy the US address and then do a trace route. So sudo trace route, just use -e, so you can have ECMP to avoid being blocked by TCP or UDP. And then let me call this address. Let me type my password, and then I will check how many hops. So those are, I'm using a trace route, I'm tracing my route. So if you see, I'm using 23 hops, 28 hops. So if I do the same command, 30 hops, wow. Let me copy the same and run it from the Australian server. Sudo apt install traceroute, because it's not available in default Debian. There is trace path, which is not the same as traceroute. Traceroute, I prefer it better. So traceroute and MTR, they are not available. You need to install them by default. Okay, please make it before we end it. Install it, because I have choose. By the way, you can choose a small machine. So you need to understand one thing before we end. Waiting for this to end. If you create a small machine, it will be free. So if you create an instance and then you choose this machine, let me dezoom, which has like, so if you choose, you need to choose US. If I choose this one, the N1, the micro, F1 micro, this machine is free. It will stay free for 1 month. So every month it gets reloaded. You just check about the free plan on GCP. Why it gets stalled? Oh, by the way, here is the standard tier, and this is where you choose the premium and the standard. So if you choose the premium, you get the best of the network. If you choose the standard, you will have a normal connection. I don't know why it's got stalled. So let me go back and try this, and then we will finish. Okay, let me open another one. SSH. And then I will use TrustPath, even if it's not, it's blocked, something blocked it. Yeah, it seems that I am not lucky in the beginning and in the end. Okay, so if I do traceroute, okay, it has been installed. It just blocked from showing me the result. Okay, let me paste command, and 1, 2, 3, 4. Here, how much we got? We got 30 hops. And here, 8, 9. This is like the hops are just the server. This is like server 1, server 2, and it hops on all the servers. So here I got 22. So you see the difference between using my own connection and using the cloud. Let me close this. Do you have any questions? No? And I'm sorry again about the beginning, because the configuration about Ubuntu, it uses what we call pulse audio. I never used that. In Windows, you just log in, it works. I need to document about this because we can't learn everything. Thank you again, and I hope this helped you. You can use the slides and go beyond, because I explained it a lot on the slides, so you can use it. Thank you very much. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuhu. We need to end it like in a real protocol. So thank you.